Hello and welcome. In this tutorial, we'll have a look at deep learning-based classification with MVTec HALCON. After a short introduction of this deep learning technology, we'll have a look at the first program in this HDevelop example series. First, what is classification? With classification, you input an image and in return get a label for the entire image. This straightforward approach makes it very easy to provide labeled data and simply try it out for your application. You can use classification to, for example, distinguish different objects, or classify objects with different defects. Deep learning classification can be especially useful when traditional machine learning reaches its limits, for example, with natural objects containing a lot of variation and complex features. Now, let's have a look at the aforementioned HDevelop example series. The ultimate goal of this application is to classify these pills with defects. In this video, you'll learn how to read and split labeled data, and how to pre-process the labeled data in preparation for training. Let's go through the example step by step. The first section of these examples contains a detailed explanation of the overall goal and process. For this video, I'll skip over this part. Next, there's a section where all the relevant paths and parameters are set. I'll explain the most important ones as we go through the example. To adapt this example for your own application, you'll mainly work with this part of the example. To get started, we first read a dataset. For classification, you can simply put the images in different folders according to their classes. This procedure then interprets the folder structure and assigns labels to the images accordingly. Alternatively, you can use read_dict to read a dataset that you labeled with the Deep Learning tool. The Deep Learning tool is a new product by MVTec with quickly evolving functionality. With it, you can label data and then train and evaluate deep learning-based models. Check out the newest version on our website. Next, the dataset is split into 3 subsets. The training data will be used directly as input for the training operator. The validation data is used to check and visualize the training progress, so hyperparameters can be adapted as needed. Hyperparameters are parameters that are not learned by the model but have to be specified by the user. By default, the model with the best result on the validation split is saved as best model by our HDevelop examples. Lastly, the test data is used for an independent evaluation after the training. The procedure split_DL dataset randomly splits the dataset using the given percentages. Thereby, it maintains the class distribution of the dataset. Note that the subsets should be independent, and each subset should be representative of the entire dataset. As a last step in this program, we pre-process the dataset. The procedure create_DL preprocess param simplifies collecting all relevant parameters. One of the most important parameters to consider is the image size you want to use. Selecting the image size is a compromise between speed and performance. The resulting dictionary can then be used as input for the procedure preprocess DL dataset. Since a lot of data is read and written, this step might take a while, especially if you're working with network-based storage. As a last step in the example, a random selection of the preprocessed data is visualized. Thus, you can check whether the relevant features for the classification are still visible with the reduced image size. Note dev_display_DL data. It's a powerful procedure to visualize your input and output data. This concludes this tutorial. The next step is to train the classification model. Thank you for watching.